The last vapor power cycle that we're going to look at is one that is a combination of two different cycles, and consequently it's called combined power cycle. And what we're going to look at is a combination of the Brayton cycle, which is a gas power cycle, the gas turbine power cycle that we looked at earlier in the course, combined with the Rankine cycle. So we can see there, typically, both when we looked at the Brayton gas cycle as well as the vapor power cycles, it was rare that we found the efficiencies of either of those to be over 40%. Typically they'd be around 35 or something like that. But what a combined power cycle does is it has a topping cycle, and quite often the Brayton cycle will be the topping cycle. And then below it there's a bottoming cycle, and that is our Rankine or steam turbine cycle. So what we're going to do now, I'm going to show you a few images of one of these systems. And what we can see here is an aeroderivative gas turbine engine that is converted for use for industrial applications. The exhaust gas would go out through a heat recovery steam generator, as you can see there, and then it basically turns the flow upwards through the heat exchanger. That's the construction of one of these systems. The heat would then be recovered, generated into steam, sent through a steam turbine like we looked at before, and eventually going into cooling towers and rejecting the heat to the atmosphere. So that's the essential ingredients of one of these combined power cycles. You can see it's a combination of both the Brayton, the gas turbine cycle, a different form of gas turbine, however. What we saw when we looked at the Brayton cycle, for example, on an airplane, that would be an aero application gas turbine engine. The one that's used for industrial applications, like we saw, would have other components on there. They're not as worried about weight, and so they will add other components that make it heavier but more efficient. And then the heat out of that goes into generating steam. So what we're going to do now, we'll take a look at what this process may look like in terms of a schematic, and it's going to be kind of a tall one, so I'll try to start right at the top of the page. So there we can see a schematic of what this combined cycle looks like. The upper half, this is our aeroderivative gas turbine engine. And you can see in comparison to a gas turbine engine that might be on an aircraft, one difference is that we have this power turbine. And the power turbine is where we get additional expansion coming out. And then the work produced from that goes directly into electricity generation. The exhaust gas from our gas turbine engine then continues to flow along, and that goes through, in our images, we had a steam generator, a heat recovery steam generator, and that was the unit that you saw with the right angle turn that was being constructed. It then goes into the heat recovery steam generator. That generates steam. And then that steam flows through a normal Rankine into a turbine. We get more electricity generation, and then we have that cycle there. So that's why we would call this the topping cycle, because it's at the top. And this would be the bottom cycle because it's at a lower temperature in terms of the temperature of the exhaust gas coming out. Now, when you have this combination, you do get enhanced thermal efficiency. And that's why it is a good type of cycle to use. It's a little more expensive, a little more complex. And the power outputs from the gas turbine are usually lower than you get from a normal vapor power cycle or a Rankine cycle. But what we can say is the work out of the gas turbine plus the work out of the Rankine, I'll call that steam. And you divide that by the heat that you put in. And the thermal efficiency of these will be higher than each of the cycles individual, and consequently it represents a very efficient way of generating electricity. So that concludes all of the vapor power cycles that we're going to look at in the course. In the next segment, what I'll do is I'll give you a bit of an overview in terms of where we are in the course, and then that will kind of set the direction for where the remaining lectures are going to be going. Thank you.